Use the trapezium rule with 5 ordinates to find an approximate value for the integral here. Show your working and give your answer correct to 3 decimal places. So here's the problem, and I've labelled it equal to I. 5 ordinates going from 1 to 3. H will equal B minus A. B is 3 and A is 1. So H will equal B, 3, minus A, 1, over the number of ordinates, intervals. 5 ordinates, so there's 4 intervals. So H is a half. So we're going up in halves from 1 to 3. Okay. So we've got x0 is 1, x4 is 3, going up in halves. So we need the y ordinates for the trapezium rule. Okay, let's have a look at this. So 1 in log 3 times 1 is 2, 2 minus 1 is 1. No, 3 rather, 3 minus 1 is 2. So it's log 10 of 2. Put 1.5 in, 4.5 minus 1 is 3.5. Put 2 in, 6 minus 1 is 5. So it's log 10 of 5. 2.5, 7.5 minus 1, 6.5. And put 3 in, 9 minus 1 is 8. Okay, there's our y ordinates then. So we've got h over 2. A half over 2 is a quarter. So the integral will be approximately equal to then 1/4 using the trapezium rule. The first and the last. So it's log 10 2 plus log 10 8 plus 2 times the 3 in between, which is log 10 3.5 plus log 10 5 plus log 10 6.5. Close the bracket for the 2 times, close the brace for the quarter times. So there's the problem then. We need to work that out. It says show your working, so you may wish to use a calculator here to get the decimal approximations of all the constituent parts to be on the safe side. I'm tempted just to proceed at the moment. So this is equal to then 1/4. Plus is times, so that's log 10 16. So it's easier to just write log 10 of 16. Plus 2 lots of, and these are all pluses, so you can times the numbers together for the logarithms, can't you? So that will save a bit of work. 5 times 6.5. Close the 2 times, close the quarter times. So now we can tap that in the calculator. So let's have a go. So it's 0.25 or a quarter times bracket log 10 16. Close bracket plus 2 times log 10 of, it was 3.5 times 5 times the 6.5. Close the bracket for the log, close the 2 times bracket, close the quarter times brace, and then go back and check where I've gone wrong. Might have had too many brackets there. Oh, it's just 2 times that single log, isn't it? So I don't need the 2 times bracket. So let's just get rid of one of the brackets. 1.32900. Which is equal to 1.329, and we needed it to 3dp, didn't we? That's to 3dp. Now the next part of the problem, there's the integral that we just worked out approximately to 3dp. If we go back to the past paper, part B then, we need to work out this with a squared, so the 2 will come down, won't it? So B, here, the integral of the log 10 of 3x minus 1 all squared dx is equal to, the 2 comes down and can just be 2 lots of the logarithm, which we labelled I above. 2 times this is 2.658, isn't it? And that was to 3 decimal places. Now if we go to the solutions, Here's the solutions here. The answers are correct. 2.658 there for B. Part A, as I mentioned, you may wish to show your decimal workings on the calculator here, because it mentions that in the question. So that might err on the side of prudence or being cautious. Here's the proper answer here that we've just done, 1.329, and the output numbers.